XLookup is one of the most powerful functions in Excel, and I cannot stop making videos about it. Today we're going to go over 4 powerful ways to use it to level up your data work, and 3 odd uses you should probably just avoid. To explore these uses, we're going to be using a dataset set in a table called scientists. If you've not used Excel tables before, they allow you to do structured references. Structured references let you reference table columns really simply. If I wanted to reference the name column, all I'd have to do is type the name of the table, which is scientists, followed by square brackets with the name of the column I'm looking for, which in this case is name. If you're not using tables, they are worth a look at because these structured references really do simplify the writing and reading of the formulas in your workbook. Let's jump into those use cases. Use case number 1 is using XLookup as it's intended. If you've not come across XLookup before, or if you have and just want a quick reminder, we're going to go through that now. XLookup works much like VLOOKUP or index match in older versions of Excel, but is a lot easier to use. For example, if we wanted to know the field of VLOOKUP as there, we could simply write equals XLookup, select our name value, setting the lookup array to be the scientist's names, and setting the return array to be the scientist fields. If instead we looked up a scientist who wasn't in the table, such as Pythagorate, we would get an NA error, much like using VLOOKUP or index match. However, unlike these older approaches, XLOOKUP's first optional argument allows you to set what happens when there isn't a match. So in this example, we could return something like not found if we didn't want errors cluttering up our data. On to the first odd use case. If you're tired of using other functions in Excel and just want to use one function for everything, XLookup is a great candidate. One way of using it to eclipse other functions is using it instead of max or min. For example, if we wanted the highest IQ in the table, we could start by using XLookup, searching for a value that we know is larger than anything in this table, looking up a match in the IQ column, returning from the same IQ column, and then setting the second optional argument, the match mode, to -1. -1 tells XLookup that if it doesn't find an exact match, to instead return the closest match it can of the value smaller than the value you're searching for. In our case, as we're looking for something way bigger than we could possibly get in the IQ column, we're going to return that maximum value. We can do the same thing to find the minimum value, in this case for the birth year. This time we'll look up a value smaller than anything in the table. To be safe, let's set it to something like -5,000. Then we look up on the birth year, return from the birth year, and set that match mode to 1, which finds the next closest match larger than the search value. This will return our minimum value in the years, which is 1452. Our second useful use of XLookup is using it as an imputing tool. If you are doing data work regularly, you're likely to have to create tables where you have to do some imputing of data. Imputing is just a fancy word for what you do when you don't know what a value is. For example, if we were trying to make a second table based on these 5 names, we would have some trouble finding their IQs as 3 of these names don't appear in that scientist table. We can then use the not found argument to say what we want to happen if we don't have a match. When imputing data, some common options include setting it to 0, setting it to the minimum or the maximum values, or setting it to the average as we're doing here. As you can see, the 3 scientists who weren't in our scientist table have been assigned the average IQ of all the scientists that are in the table, but we could have just as easily set this to some other value, such as the minimum, the maximum, or the median. The second odd way to use XLookup is using it instead of the ceiling and floor functions. Ceiling and floor simply take a decimal value and round it up or down to the nearest integer, respectively. To do this with XLookup, we're going to have to create a list of integers spanning from the lowest value to the highest value we're going to need. Here, we're applying these calculations to Leonardo da Vinci's impact value, which is 8.8. With ceiling, this would rise to 9, and with floor, it would drop to 8. We can see from the table that all the impact values are between 6 and 10, so we'll make a list that goes through all of these integer values. We can then look up Leonardo's impact factor within this list of integers, returning from this list of integers, and set that match mode to -1 for floor and 1 for ceiling. The third use case we're covering is dynamic arrays with XLookup. Dynamic arrays allow more modern functions to process and or return multiple values at once. Even better, there's more than one way XLookup is built to handle dynamic arrays. The first is using it to return multiple columns at once. For example, if we wanted the values for all the fields for a given scientist, in this case Leonardo da Vinci, we could simply use XLookup to look up Leonardo da Vinci in the names column, and then select all the other columns from field all the way to impact, and we would get all of these returned in our result. The other way you can use XLookup with dynamic arrays is to pass multiple values into XLookup. For example, if you wanted to look up the field of all of these scientists, we could say XLookup, select all of them at once, look that up in the name column, returning the field column, and we get the results for each of them in turn. Unfortunately, you can't combine these two approaches, so you can't return multiple columns or multiple lookup values at once, but it's still a really powerful use. For our final odd use case, we can use XLookup to check if something is in a list, replacing isNumber match or isNumber X match. And I'm not entirely sure this is that odd. For example, to check if each of these scientists were in our table, we could simply look up the scientist's name within the name column, returning from the name column, otherwise returning some other value, and set this whole expression to equal the name we're looking up. To be extra safe, I like to change the not found argument to be the value we're looking up concatenated with some other additional string. This will return true if the scientist appears in the table, and false otherwise. Our final and most powerful XLookup approach is using XLookup's dynamic array functionality to perform two-way lookups. The index match approach of old lets you do a two-way lookup by including two match statements, so it's great to have a way to do this using XLookup as well. To do this, we're actually going to use two XLookup expressions nested inside one another. First, we'll look up the name of the scientist in the scientist names, returning all of the fields as we did in the first dynamic array example. We then make this entire expression the return array for a second XLookup. That second XLookup is going to take what value we're looking for and look that up in the headers of the table. With the initial dynamic result as its return array, we're able to perform that two-way lookup. If you want to check out me using some of these odd XLookup approaches in an Excel esports environment, why not check out one of my Will It XLookup challenges. I hope you found this useful and entertaining. For now though, that's all from me, so until next time, keep excelling.